Hello guys, myself Ankush Gupta here at the Gate Coach, and I hope you guys are doing well and you had quite a good experience at your Gate 23 exam in chemical engineering. If you remember, in classes and in many other videos, I have told you that Gate 23 is going to be relatively easy for you if you just prepare hard, because this time also there were not many students who were fully prepared for the exam. As I can see, I can tell you, जैसा मैंने अपने स्टूडेंट से मेरी बात हुई थी, I have discussed with many students and solved, guided them and observed their performance in the test series also. So, not from all over India, I can say, not all the students were prepared. Okay, only some, you can say 20% of the students, 10 to 20% students were prepared early for this exam. So even if you score about 60 or 65 marks, you will be definitely having a top 100 rank in this year exam. Okay, that is my idea after observing the paper. मैंने भी पूरा पेपर दिया था इस बार, just to take the feel, just to see what type of questions they are asking and what is the pattern and the other things. So I observed one thing, that this time the paper was not that much kind of lengthy as it was last year in 22, but yeah, still there were quite a questions which you can see were kind of out of the box type, but not many like the previous year. But yes, if you are scoring somewhere between 60, 65 or 55 plus, then you have a very good chance to crack the IITs for MTech or the PSUs. Okay, so here we will discuss the solutions for some of the questions from the today's exam. So let's start. Okay, and in the meantime, in between the discussion, I will also share my analysis, what I felt after this exam, what type of questions were there and how many questions were there from each subject and all other things. Okay, so obviously we will not be able to discuss all the 65 questions here, you can understand, because the paper was online. So no one has all the 65 questions except you guys. So if you find any question missing, so you can share that to, you can mail us or you can share the question on our comment box, okay, or in the live chat also. So let's start the discussion from process calculation. One thing which I can tell you, that in process calculation, obviously, as we know, I told you earlier also, the weightage will be about 4 to 5 marks, and this year 3 questions were there from process calculation, and for the 5 marks, 1 question for 1 mark and 2 questions for the 2 marks. Okay, so the first question which was there for 1 mark was something like, we are sending 100 moles per hour of methane in a combustion chamber, and out of this only 50% methane is converted. So what will be the theoretical requirement of oxygen? What will be the amount of oxygen required theoretically? That's what they asked. Okay, and it was given that in the combustion chamber, after combustion, CO and H2O vapor, and obviously since 50% conversion is there, so some 50% or will also be there, and all other things are also there, but we don't care about that thing, since we have to calculate the theoretical requirement. So you know that we calculate the theoretical requirement for 100% conversion and complete combustion. And what is the complete combustion of CH4? You guys know that that will be into CO2 and H2O. So here will be the complete reaction. And from this reaction, you guys can easily see that for 1 mole of methane, we required 2 moles of oxygen. So obviously for 100 moles per hour of methane, we will require 200 moles per hour of oxygen. So this is the theoretical requirement and this is the answer. I hope it is clear to you, guys. If you wish, you can also mention answer in the chat. You can ask your questions. You can discuss the things. So I hope it is clear. And the people who will join late, you can also watch the recording later on. The second question was for 2 marks. Wet air having 10% water vapor passed through a column having CaCl2 pellets. Having 10% moisture content passing through a column having CaCl2 pellets where 50% of the water is removed. So they are asking what will be the mole fraction of water vapor in the air leaving. So quite a easy question for 2 marks. Okay, you can see these are the free marks, okay, which anyone can get easily. So you can choose the basis as 100 moles of wet air going. So in that case, you can see the wet air will have the moisture content, that is 10 mole, and the dry air that will be 90 mole. Okay, since 50% of the moisture is removed, so out of this only 5 mole will go in the outlet, 5 mole of moisture content, and the dry air will remain as it is. So here you can see the mole fraction of moisture content will be 5 over 95, whatever is the value. That is 0.0526. Percentage mole fraction they asked, so it will be 5.26%. So I hope it is clear to you guys. Okay. So this was one question. And the third question from PC. And the last one for 2 marks of again. That was also quite a easy question. It was given that offset analysis of a stack gas was as follows. Stack gas and the offset analysis is given, where we were having nitrogen, CO2, CO and oxygen. 65% nitrogen was there, 15% CO2 was there, and 10% CO and oxygen were there each. So you can see total 100%. So it is obvious H2O is not there and this is total 100%. So this is dry basis analysis. And it was also given in the question that the gas, by some humidity experiment, it was found that the stack gas also have 7% H2O vapor. Okay, so you have to find out the mole fraction of nitrogen on basis. So I hope one thing you understand that offset analysis means the dry basis analysis. In the calculation, we ignore the H2O there and then we find out the mole fractions. So here you can choose the basis as 100 mole of stack gas based on Orset analysis. That will be easy for you to always choose the basis on the data which is given. Okay, so in that case you can understand the nitrogen will be 65 mole, CO2 will be 15 mole, CO will be 10 mole, and oxygen will be 10 mole. So that's how total 100 mole of stack gas is there based on Orset analysis. Apart from that, H2O is also there, H2O vapor, which is 7%. So just try to understand. Okay, let total P mole of gas is there. P mole of stack gas is there. Okay. So in this P mole of stack gas, we have all the gaseous components CO2, N2, CO, O2, etc. plus H2O vapor. So what will be the amount of H2O here? That is total amount multiplied by its mole fraction, that is 0.07. Okay. And what will be the amount of, this is H2O vapor. Okay. And what will be the amount of all other gases? All other gases. That will be P into 0.93. I hope you understand that. So total P mole of stack gas is there, suppose, total overall, okay, in which 7% moisture is there and 93% all other gases. So amount of H2O vapor will be this, and so amount of all other gases will be this much, and which is equal to what? Which is equal to 100 mole we have taken. So from there you guys can calculate the value of P, that will be 100 over 0.93, which will be about 107.56 or what? 107.53. Okay, so this is the total amount. So you can understand what is the mole fraction of nitrogen now on wet basis, that is moles of nitrogen divided by total moles including H2O, that is 107.53. So you will get your answer, that will be about 0.6. rounded off to one decimal place. So I hope it is clear. This is all from the process calculation, total 3 questions of 5 marks. Okay. Now next we will talk about the mechanical operation. The exact question I don't remember, and whatever data I have, based on that I can tell you the things. Okay. So in MO there were 2 questions only from mechanical operation for 3 marks this time. I don't know why, but unfortunately, because mechanical operation, you know, is one of the score subject where any one of you, all of you can easily get all the 100% marks. Okay, but anyways, here we were having only 2 questions, so we will discuss those 2 questions only. So first question was related to fluidized bed, where the fluid is flowing through a fluidized bed where under laminar flow conditions. So obviously the Kozny-Karman equation was valid, and it was also given that the particle Reynolds number was less than 1. So from that also it is obvious that is laminar flow regime. And for laminar flow regime, you know that when fluid passes through a bed of particles, so based on the Kozny-Karman equation, the pressure drop per unit length is given as 150 mu v 1 minus epsilon whole square over phi dp square into epsilon cube. So here they said that the velocity of the fluid is directly proportional to the diameter of particles power n. will be the value of n? They were asking. Okay, so this was for 1 mark, this question. So here you guys can see from this Karman equation. So if you know the equation, you can directly answer. This was this type of question it was. So V is proportional to dp square. We can see that. So n will be equal to 2. That is the answer. Okay, this was for 1 mark. Simple. Okay, so I hope it is clear to you guys. And the next question was from the settling part, the sedimentation part, where generally discuss the terminal settling velocity, but in the exam they asked for the terminal rising velocity, but doesn't matter, you know the things. It was given in the question that Stokes law is applicable. The diameter of the particle was 100 micrometer. The density of fluid was 1 gram per cubic centimeter. Density of particle was 0.8 gram per cubic centimeter. G was taken as 10 meter per second square. And the viscosity of water was the fluid, was 10 to the power minus 3 Pascal second. So this much data was given and they were asking what will be the terminal rising velocity of the fluid, of the particle. So from the question it is obvious, from the data it is obvious, you know that if the density of particle will be greater than the density of fluid, particle will sink, it will settle down in the fluid. So we will calculate the terminal settling velocity. And if the density of particle is less than that, so obviously particle will rise in the fluid. So in the question it was given that we have a container filled with water and a particle was released from the bottom of the tank. Okay, and after some time particle was able to attain its terminal velocity. So what will be the absolute value of terminal velocity, they were asking. So absolute value itself means you have to give the magnitude only. Okay, so you know that from Stokes law design, the terminal settling velocity of the particle is given by this equation. And if it is for terminal rising velocity, so just put one minus sign here because only the direction is different, nothing else. Okay, although if you do the, you know the method, I hope how we got this equation. So if you do the proper force balance, still you will get the same equation for rising. Okay, so anyways, doesn't matter. So since we are concerned with the terminal rising velocity, so we will use the minus sign and we will put the values. Diameter was given 100 micrometer, or you can say 10 to the power minus 4 meter. So just put that value. G is given as 10 meter per second square. And rho p minus rho f, I hope you know how to convert this gram per cubic centimeter into kg per meter cube, SI units. So for rho p will become 800 and rho f will become 1000 kg per cubic meter. So here viscosity is 10 to the power minus 3 Pascal second, or you can write kg per meter per second. You know the units, I hope. So when you will solve this, you will get your terminal settling velocity in meter per second, which you can convert into mm per second later on. So your final answer will be 1.11 mm per second. So I hope it is clear to you guys. So this was from mechanical operation part only. So now we have the Jensor and he will discuss the aptitude part with you guys. Then we will continue other things.
The apti part was one of the easiest this year, and I don't think any of the students who studied for at least few days, say 5 to 6 days, was not able to solve any of the question. So the first is, what will be the coefficient of x to power 4 in the polynomial x minus 1 to power 3, x minus 2 to power 3, right? So answer is, I'm going to write the answer first. Answer is 33. How come? How is possible? That will expand that x minus 3, x minus 1 to power 3 and x minus 2 to power 3. That is x cube. Can you reduce it a little bit? Yeah. Okay. That is x cube minus 3x square plus 3x minus 1, and that x minus 2 will be x cube on the similar manner, 6x square plus 12x plus 8. All right. Once you will solve this, it will come x to power 6. Need not to solve all this. You have to solve only for the x to power 4. But I have solved everything. That is 9x to power 5 plus 33 x to power 4 minus 63 x to power 3 minus 36x plus 8. All right. So answer is 33. Right. The next question. You are the seats. Okay. In the following kilogram, what is RS? This question, a few of the students are saying that this question is wrong or some problem is there. But once I have seen that actual picture of the this parallelogram, that becomes quite easy. So it is like this roughly, and here it is a 90-degree. There are few things given to you to confuse you, right? And this is also 90-degree. Right, these are the two projections. So area of parallelogram is B into H. So once you'll multiply that, this is say V and this is say T, right? Once you multiply PT with PS, you'll get the area. On the similar manner, you'll multiply PV with SR, you will also get the area of the parallelogram. Right. So this PT is 4 and this is 7 given to you. This is given 7 to you. This is given 5 to you, and this is sorry. And this is given to you is 5. This is given to you is 4. All right. This is T. This is Q. This is P. All right. So what we have to find out? Say this is S and this is R. All right. So we'll put the value. This is 4 into 7. This is 5, and you have to find SR. So SR will come 28 by 5. I think this answer is given to you. Otherwise, it might be 5.6 also. Whatever given the option, I don't know there. This is the answer, right? Okay. One good question was there. That is from the special aptitude, and a figure has been given like this. The 4 by 4 right. Can I change the color, Ankush, from where? So say there is one line like this, another line like this, right?
Red might not be visible.
Huh?
Red will be not visible.
Okay, what to do?
You can take yellow.
Okay, so this was the line and this was the line, and says that it should be a mirror image, and some blocks are already filled. So this block is filled, and this block is filled, and this block is also filled, and these 3 blocks are filled. So if this is filled, we have to fill this also, right? So this is also filled. So in corresponding to this particular line, these 2 are filled. these two are say filled. If this is filled and corresponding to this, we have to fill this. Once you'll fill this, for this line you have to fill this, right? And if you'll fill this, right, for the you will fill this for this particular line, straight line, you have to fill this also, and for the straight line you have to fill this also. So this for this image, this and this is the mirror, this and this is the mirror, and this and this is the mirror, and this and this is the mirror. For this particular line, this and this is the mirror, this and this is the mirror, this and this is the mirror, and this and this is the mirror. So you can count. You have to fill 5 blocks. So answer is 5. Very easy, very easy. It happens sometimes in fresher you are not able to answer this question. So it's simply saying that across this line and across this line, it should be exactly mirror image. So already they have filled 3. You have to fill more 5. So total filled will be 8. So it is saying that how much you have to fill. You have to fill 5 only. Right? Another one. Yeah, which of the following shape can be used to tile completely cover or repeating a flat plane extended to all direction without requiring any empty space in between them? The copies of the shapes used to tile are identical, are not allowed overlap. So options are rectangular, pentagon, circle, rhombus, and rectangular octagon. You might have seen that it will use hexagon. You know, even in the cell phone, we call it cell phone. Why? Because tower is located in the center, it covers a hexagonal area. So there will not be any gaps. You will use circle, there will be few gaps, right? So what we need, Ankush, please clear everything. Okay, so how, so we need hexagon to hexagon, or say square, or say uh, any shape which will not leave any space in between them. So pentagon will leave space, circle will sorry, excuse me, circle will definitely leave space, octagon will also leave space, but in case of rhombus, we'll use 3 rhombus. Say this is a sorry, so this is a hexagon. I think, yeah, this is hexagon. You can divide hexagon. Octagon हो गया? No. Wait a minute. 1, 2, 3, 4, 5, and 6. All right. So what you can do, say you can divide one hexagon into 3 rhombus shapes. Right. It will make it correct, like in a correct scale. Wait a minute now. Actually, you have to create according to scale. Every size should be equal. So actually, 3 rhombus will create one hexagon, right? Like this, like this. So this is 1, this is 2, and 3. So answer will be hexagon. If we'll use 3 hexagons, it will make 3 rhombus. It will make a hexagon, and hexagon will not leave any space. Will create tile with the help of that. Right? So this is the answer. We have done this. We have done this. Okay, we have done this. Hmm? And cement wala na? Okay, this you and you are this English question na? The English question are see, you are delaying the completion of task. Send your contribution at the earliest. The answer is your reference. Then blank, then guidelines and implement. The answer will be CITE. Right. What will the coefficient that you have done? Sand and cement are mixed in a ratio of 3:1. The cost of sand and cement, what is R in ratio of 1:2. Total cost of constructing wall is 1,000. What is the cost of the cement used? So the ratio of the sand and cement is 3:1, and the ratio of their price is 1:2. So 3:1 is to 1 is to, oh, what is going on? Okay. 1:2. Actually, we have to divide them into 3:2 price. So total price is 1,000. I'll divide it by 5 parts, and 2 part of that is cement. So that will be 5, 200. Answer will be 400 rupees. Again, disclaimer is these are based questions. So if some data is missing, the answer may. If the data is correct, the answer is absolutely. So we are going to get more questions. Once we'll get more question, we'll update it. We are updating answers on the Facebook page also. That is by the name The Gate Coach. So please find it there. Have missed anything, then go there and you can check it. If you are having questions, please send it to us. I'll be able to send it to us. We will be able to solve those questions within few minutes, and we will be able to solve it. Right. Thank you. Anything? Yeah. Please continue. So till now, whatsoever the aptitude question we have found, we have solved it completely. Uh, those are our students. They have studied in the class. I have heard that there are few syllogism questions for there, and we have studied syllogism in the class. So they might have solved it. Thank you.
So so it was from aptitude part, guys, where Jen sir discussed some of the aptitude questions with you. I hope it was helpful for you. Now we have some questions from thermodynamics, CRE, and some other subjects also. So first, let's the questions from thermodynamics part. And as I know this time, the thermodynamics, there were only 5 questions for 7 marks. Okay, 2 questions of 2 marks and 3 questions of 1 mark. So the first question we got was, it was related to some experiment. Okay, I don't remember the exact statement, but the question was something like that there were 2 guys performing some experiment on a thermodynamic system where the initial and final state of the system was given. The initial state was X and the final state of the system was Y. One guy was doing the experiment in a reversible manner. So for him, the entropy change was delta S ReV, and the other guy was doing the the experiment irreversibly. So the entropy change was there given by delta S IRR. Okay, so they were asking actually what is the relation between these two. So there were some options like delta S ReV greater than this, less than this, equal to this, or something like that. Okay, there were 4 options. So the correct answer will be, I hope you know the answer, they will be equal, because entropy, is the state function, is a property, is a point function. It does not depend on the path. So if the initial and final state of the system are given, if the initial and final state of the system are fixed, then their property change will also be constant, same. So delta S ReV will be equal to delta S IRR. So I hope it is clear to you. This was the answer. And then there was a question related to Carnot engine, that some Carnot engine is operating in between a source and sink, and you have to find out the incorrect statement. Okay, this was one MCQ type question. So there were 4 options, if you remember. First, engine is reversible. Engine is reversible. Second option was, efficiency of the engine is independent of source and sink temperature. Third option was, efficiency of this engine will be maximum. And fourth option was, the total entropy of the system will increase with each cycle. in the engine. Okay, so I hope you know the answer. Engine, Carnot engine is the reversible engine, so that's the correct option statement. But we have to figure out the incorrect statement, so we will cross it. The efficiency of Carnot engine depends on the temperature of sink and source. We know that F eta is equal to 1 minus TL by TH. So that is also the correct statement. But since we have to mark the incorrect options, so we will ignore it also. The efficiency of the engine will be maximum among all other engines operating between the same source and sink. So that is obvious. The Carnot engine has the maximum efficiency, and that is the Carnot efficiency. So this is also the correct statement. But as per the question, we will ignore it also. So this will be the correct answer, because in the engine, you know that entropy is a point function. Okay, and when the engine is operating in a thermodynamic cycle, so entropy change must be zero. As you know that the cyclic integral of all the thermodynamic properties is zero, so obviously the cyclic integral of entropy will also be zero. So entropy will not increase or decrease. Okay, so D will be the incorrect statement, so we will tick D as the answer. That entropy of the system total entropy of the system will increase with each cycle. This is incorrect statement, and that is our answer. Okay, so now the next question. The next question was given that for a reversible endothermic reaction, it is from chemical reaction equilibria, if you remember, solution thermodynamics. For a reversible endothermic reaction, the equilibrium constant K and the temperature, the dependency of equilibrium constant K with the temperature is given by the following options. So what will be the correct answer? Okay, so if you remember, the equilibrium constant is related by standard Gibbs energy change like this. And when you see the effect of temperature on equilibrium constant, then we get the equation d ln k over dt equal to delta H naught over RT square. Okay, and here for endothermic reaction, I hope you remember that for endothermic reaction, enthalpy change will be positive. So even if you don't know or you don't want to integrate and solve this and all, so you can do one thing. If you do the integration of this, I hope you remember ln k2 by k1 will be equal to delta H naught by R over times of 1 by T1 minus 1 by T2. And if you guys remember, so this equation is quite similar to the Arrhenius law, that is ln k2 by k1 equal to E by R 1 over T1 minus 1 over T2, where we know that activation energy E was positive, and for Arrhenius law, the relation between ln k versus 1 by T was given by this. Okay, the straight line. So similarly, for this case also, since delta H is positive, so you can make an analogy also. So based on that, you can say this is the answer, obviously. Otherwise, you can solve this also. Okay. You can integrate this, you can find K with in terms of T, and then you can convert that in terms of 1 by T, and then you can solve. You will get the same answer, this one. Okay. So I hope it is clear to you guys. Now the next question was from the partial molar property, and it was given that the molar enthalpy of a solution, binary solution, was given by 40x1 plus 60x2 plus x1 x2 times of 4x1 plus 2x2, and they were asking the partial molar enthalpy of component 1 at infinite dilution. Okay, so I hope you know partial molar enthalpy of component 1 at infinite dilution means the x1 will tends to 0 and x2 tends to 1. Okay, so I hope you guys can solve this. So if you remember H1 bar or H2 bar, what we will have to calculate? H1 bar, I didn't find it. So we know that H1 bar can be calculated by H minus X2 times of dH over dx2. So you just need to solve this and you will get your answer. So H is given this. So first we will convert this because we want to differentiate H with respect to X2. So we will convert X1 in terms of X2 there. Now you can differentiate this with respect to X2. This part as it is, differentiation of this part as it is, differentiation of this. So now if you multiply by X2 here, it will become 20x2 plus x2 times of minus 2 x2 x2 minus x2 square plus this part. Okay, I'm not solving this here because you know that what you have to calculate this part. Okay, so just put the values here and solve directly. Okay, you don't need to do the expression because it is not required, you just need the values. So when you will put this value x1 0 and x2 1, first we have to put these things in H. So in H, when you will put x1 0, so this term will vanish, this will vanish, and we are left with 60 minus this part. Okay, in this expression you can put x1 0 and x2 as 1, means this value. So when you will put x2 1, it will be 20, 1 minus 1 0, vanish, plus 4 minus 2 2 multiply by 1 minus 2, that is minus 1. So you guys can solve, you will get your answer. 42, if I am not wrong. Okay, because I have done the calculation directly, so you guys can check by yourself what is your answer. But this is the method, that's how you guys can check. 42, okay, thank you IITN Baba. So this is the answer, guys. That's how you can solve these things. So the next question from thermodynamics, again it was quite, see till now in thermo we haven't got any difficult question, all the questions were quite easy as you can see. Okay, now one more question was given from the phase equilibria part, that is the fugacity in solutions. If you remember, it was given that in a container water is filled which is in contact with the air at 100 kilopascal pressure and having 3% CO2. These two systems are in equilibrium. Henry's law is applicable, and the Henry's constant for CO2 in water was given as 12 megapascal, I guess. Yeah. So what will be the mole fraction of CO2 dissolved in water? So from the Henry's law, I hope you remember that. Even if you don't remember, so just you know the Lewis Randall rule. Okay, so from the Lewis Randall rule, you guys know that fi cap is equal to xi into fi, or you can directly write it as fi cap is proportional to xi. Okay, so from there also you can use it to solve. So it was given that air can be taken as ideal gas, so fi cap will be equal to pi bar. You know that when you will remove the proportionality sign, some proportionality constant will come. In case of gaseous solution, it will be Fi. In case of concentrated liquid solution, it will be PIV. But in case of diluted liquid solutions, you know that the proportionality constant will be Ki. So here you guys can put the values. You know that partial pressure can be written as mole fraction into total pressure. Okay, so you guys can put the value mole fraction of CO2 in gas 0.03. Total pressure was 100 kilopascal. Mole fraction of CO2 in liquid was unknown. K was given 12,000 kilopascal. Was 12 megapascal, or you can say 12,000 kilopascal. So when you guys will solve this, you will get mole fraction of CO2 in liquid. This question was there for 2 marks. Strange. So your answer will be 2.5 into 10 to the power minus 4. Simple. This was the option. Okay, there were four options, obviously. So this was the correct answer. I hope it is clear to you guys. So these were the thermodynamics. Okay. So here our thermodynamics is also completed. Now I have some questions from mass transfer and some questions from CRE, which I will discuss. But before we talk about that, one thing I want to tell you that whatever things I have seen in this exam, okay, if we see, okay, there are we have aptitude portion, math portion, then in technical section we have PC, thermo, FM, MO, heat transfer, mass transfer, CRE, instrumentation and process control, and chemical plant design economics, and chemical technology. So if you try to analyze this, you guys can do it by yourself. Okay, I will not tell you anything new. Every one of you already know these things. So I'm just telling you how you can analyze your result by yourself also. Okay, you don't need to go anywhere. You don't need to wait for the things. There were 5 questions of aptitude for 1 mark and 2 marks each. So I hope you guys have quite a good idea by yourself that how many question in aptitude you have attempted. Okay, so based on that, if you have attempted 3 question in 1 mark, or 4 question in 2 mark, or five each, or what, based on that you can see what is your marks in aptitude section. Okay, out of 15, obviously. Then mathematics, obviously, for 13 marks, 5 questions of 1 mark and 4 questions of 2 mark. This was the mathematics in this year grade 23 exam. So you can see by yourself out of 13 how many marks you are getting. You can understand easily. Okay, we are providing some solutions, or otherwise in next 2 days you will get all the solutions on our channel, or otherwise from the Gator website also. Okay, from the application portal. If you know, after 2 days they will provide you the response sheets, so you can check by that also. Okay, so anyways, so you can evaluate yourself that how many marks you are getting in mathematics out of 30. Okay, same PC. There were one question of 1 mark and two question of 2 marks. Total 5 marks with PC was there. And as we have seen, all the three questions are quite easy in PC. In aptitude also, I believe that not 10, but at least you should be able to solve 7 or 8 questions. That was the basic. Okay, okay, okay. Because the aptitude is quite easy. In GATE exam, the level of aptitude is very, very easy. Anyone can easily solve all the 7 8, not 10 but at least 7 8 questions. As Jenser also told you, that even if you have done the aptitude practice only for 4 5 days, still you should be able to solve 7 or 8 questions there. Anyways, thermodynamics, 3 questions of 1 mark and 2 questions of 2 marks, so total 7 marks questions were there. Okay, and as we have seen in thermodynamics, this year thermodynamics, all the questions were quite easy. All the 7 marks score. Okay, but anyways, in fluid mechanics, only 4 questions were there. 2 questions of 1 mark and 2 questions of 2 marks. This time, fluid mechanics, the weightage was quite low. It was surprising, but doesn't matter what we can do. Ammo, 3 marks only, one question, which we have done. Both are easy. Heat transfer, three question, total 6 questions, and 9 marks weightage was there. In mass transfer, 4 questions of 1 mark and 3 questions of 2 marks were there. So total weightage was about 10 marks. I always say in the class also that mass transfer is generally about 8 to 10 marks only, not more than that. That is the general weightage. Okay, most of the time you will get mass transfer anywhere between 8 to 10 only, not more than that or less than that. It is rare that you get mass transfer or heat transfer out of that range. CRE, this time CRE was quite means very, only 4 questions were there of 8 marks. Okay, so CRE was not that much. Generally, they ask almost 10 to 11 marks question from CRE every year, but this time it was quite low. Okay, but on the other hand, from instrumentation, it was quite high. The 11 marks IPC was there, but if you see overall, I always say that combined weightage of CRE PDC is about 20 marks only, and here you guys can see the combined weightage is about 21 marks. Okay, sorry, 19 marks. 8, 3, 11, and 4, 19 marks. Economics was quite a 3 questions were there of 2 marks. So 6 marks economics was there this time. And CT was also quite high. This time there were 7 marks questions from chemical technology. So these are your 65 questions, and I hope you know how many questions you have attempted. In 2 days, after 2 days you will get your response sheets on 15th Feb. Not 2 days exactly. Sorry. Tomorrow also we have gate exam for other streams, but after that. Okay, so on 14th or 15th you will get your response sheet, so you can check by yourself also that how many marks you are getting in each subject, or so that's how you can score the things, you can sum up your marks. And one thing which I can tell you, if you are having marks anywhere between 60, okay, then definitely your rank will be in top 100, because competition was not there. Although if the same paper, okay, if the same paper was given in year 2019 or year 2020, so I would say that, or that time we can say that the for top 100 it was 70 marks paper actually. Okay, if you are a top 100 ranker, so anyone can easily get 70 marks. But since we are in 2013, sorry, 23, and most of you people and your friends are those who have done their BTech in online mode. So I know you guys are not that much strong in your basics as the BTech student is supposed to be. So that's why I'm saying the competition is quite low, and anyone who is getting marks anywhere near 60 plus minus 2, you can see easily can get top 50 to 100 rank. Okay, and if you are just thinking about the cutoff, means you were willing to just qualify the exam and your focus is only on cutoff only, so then I can also say that the cutoff marks will not be more than this, anywhere between 30-32, to be precise. This time cutoff will be little high as compared to 22. 22 was, you can say, the worst year in the history of competition, because most of the people who were competing were not ready. Okay, due to the lockdown and some corona and all other stuff. But this time they were fairly ready, but not properly. So still, cutoff will not be very low, but yeah, it will be somewhere about 30-32 marks, I guess. Okay, and I believe this. So if you are having marks in 55 plus 60 range, so you can think about your further preparations. You can just take a break for 1 or 2 weeks, enjoy, because you have done quite a lot preparations in last 6 months or 1 year. Have a travel plan or Valentine plan or any other plan. Just enjoy for 1 or 2 weeks, and after that start preparing for the interviews. Okay, because if you will make your plan for more than 1 or 2 weeks, it will not help you, because if you are having your marks, if you are thinking that you are going to get marks anywhere between 55 plus, then trust me, you will definitely get an interview call from IITs for masters, from the PSUs, from BARC, or any other organization which is there, or any other institution. So start preparing for your interviews. You can take a week off for 1 or 2 weeks only, but not more than that. But if you are thinking that you are getting marks less than 50, okay, less than 55, then you can contact us. We can have one-on-one communication, and I would like to help you. I would like to guide you what you can do best, or what. Okay, so the people who are getting marks above 55, just relax, go for the vacation for 1 or 2 weeks. You deserve that, obviously, after the preparation of 6 or 7 months which you are doing from last 6-7 months, I believe. And after that, start your preparation for the interviews directly. Now let's get back to the topic. The topic of the video was not analysis. We will do the analysis again, proper detailed analysis later on, when we will get all the 65 questions after the 15th Feb. But now there was a question from mass transfer. I don't have all the questions. So whatever questions you guys have sent me or I was able to recall, we will discuss that only. So there was a question on distillation column, where the flooding velocity was given about 0.15 meter per second, and it was given that the column is operating at the 60% of flooding velocity. Okay, and the volumetric and the molar flow rate was given, molar flow rate of the vapor was given 0.1 kilomole per second. So you were supposed to find out the column diameter, where some other data was also given. So I hope you know that if you want to calculate the column diameter, so you know that column diameter you can calculate as with the help of cross sectional area, which will be the volumetric flow rate over velocity. Okay, from the continuity equation for incompressible fluid, you know that. Okay, so here you can convert this molar flow rate into volumetric flow rate by using molecular weight, which was 45 kg by kilomole, then density, which was 20 kg by meter cube. So that will give you the volumetric flow rate in meter cube per second, that will be 4.5 upon 2, 2.25 meter cube per second, which should be equal to the cross sectional area A into velocity. So operating velocity we will use, which is 60% of flooding velocity, that will be 0.09 meter per second. And cross sectional area, I hope you guys know that pi by 4 d square. So here you guys can put the values where v is 0.09. So after solving this, you guys will get d, that is 10 upon root pi meter. Okay. So I hope if the data is correct, so this was the answer, or it is the answer. So that's how you guys can do it. Okay, it was quite an easy one. And there was again one question, I think, related to diffusion, where the equimolar counter diffusion and diffusion of A through stagnant B was given, and you have to find out the ratio of flux. So something was that. Okay. So I hope you guys remember that if you talk about the flux when diffusion of A occurs through a non-diffusing B, so the flux can be calculated by the following equation. And for the case of D and D, we can say in short. And for equimolar counter diffusion, it is like this. So whatever ratio they were asking, you can calculate. I think they were asking the ratio of flux only. So that will be equivalent. That will be only XBLN term will be there, and the mole fraction was given. Okay. So the mole fraction was given there for component A or B. I don't know what. So you just need to convert that value into XBLN, and then you will get your answer. Okay. Uh, I don't know the data, so I hope you remember that. Otherwise, you can try that. That's how we can solve it. One question was there on batch distillation. I remember. Okay, where in batch distillation some feed was introduced this much amount of A, and after some time relative volatility was also given, and the final amount of A was also given, and they were asking about the amount of B. Okay, some this type of question was also there. So if any one of you remember that, so you can share the data of that question. But otherwise, I hope you know that you can use the Rayleigh equation to solve it. Okay. Anyways, so only these question I had on mass transfer, these two, and one question I have told you. If you have any other question, you guys can share. We will provide the solution for that also. Okay. Now from the CRE part also, there were only 4 questions, and I have only one question with me right now, unfortunately. Actually, 2 questions I have. One question was, and all those 4 questions were there for 2 marks only. One question was for a reaction A gives P, the batch reactor performance data was given as 0.45, 0.35, 0.31, 0.18, 0.11, 0.05. And here CA naught was given 1. So they were asking for XA equal to 0.8, what will be the space time in CSTR for the same reaction. Okay, so this was the data given for batch reactor, and based on that they are asking the values for CSTR. So first thing is there is no analogy. We can't relate batch reactor with CSTR, but one thing which we know, for CSTR, the design equation in terms of space time is Ca naught into Xa over minus Ra. This is the design equation, we know that. And one thing which we also know, that this is rate of reaction, and rate of reaction is independent of type of reactor. Rate of reaction depends only on the reaction conditions. So it was given in the question, if I am not wrong, for the Xa equal to 0.8, for the same reaction conditions, what will be the space time in CSTR? Okay, so here Ca naught was given 1, Xa is 0.8. So for Xa equal to 0.8, you guys can see rate of reaction is this. And rate of reaction is independent of reactor type. It is a function of reaction conditions only. For the same reaction conditions at X equal to zero point 0.8, Ra is this. For batch reactor, for PFR, for MFR, for any other reactor. Okay, we will put the same value. Sorry if the units were inconsistent. I don't know, but I think that it was consistent. Otherwise, you guys can convert the units. I hope you know that how to do that. So after solving this, you will get tau. What will be the value? 80 upon 5. 16, I guess, seconds or minute, whatever the data was. So that this question was there for 2 marks. Yeah, see, quite a easy one. You don't need to think anything extra. Just put use the design equation, put the values, and get your answer. Even you don't need to use any calculator for this. Okay. So this was one easy question. One question was related to surface reaction mechanism. Okay, we have got almost 3 questions from that. So E curve was given for some second order reaction, and it was kind of a staircase where it was given that the value of these 3 sections, 1, 2, 3, area of these 3 sections, 1, 2, 3, was same. Okay, so only this was data was given, and K was given, I guess, 0.2 or 0.5, I don't know, 0.2, yeah, and Ca naught was given 1.5, and they are asking the mean conversion. So from segregation model, I hope you guys know that Xa bar will be equal to integration of Xa into Et dt from 0 to infinite. So here it will become Xa into E1 t dt plus integration from 10 to 15 Xa into E2 t dt, because these are two different curves, as you can see, 1 and 2. Their intercepts are different, so obviously two different curves. Okay, so here Xa you can find out from kinetic equation. I hope you remember, for second order reaction it will be Kca naught T over 1 plus Kca naught T, and after putting the value of K and Ca naught, you will get Xa equal to 0.3 T upon 1 plus 0.3 T. Here you don't know the value. Okay, so one thing I hope you guys know, that area of E curve will always be 1 in the total time interval. So here this area you guys can see will be, if you consider this value to be y, let's say, so this area of this rectangle first and second will be 5y plus area of second rectangle 3 will be 5 into, what is this value? If you see, all these 3 rectangles or square, whatever it is, are same, it is given. They have the same area. So obviously this value will be y by 2. So this will be 5y by 2. So after solving this, you guys will get y. And based on that, you will get these two values, and which will give you E1t and E2t. Okay. So what will be y here? 15 upon 15 y upon 2. 2 upon 15. So this value will be 2 upon 15 and this value will be 2 upon 30. So you can see the even t will be, as the slope of these curves is 0, you can see horizontal lines. So c y will be equal to c only, mean y, you know, straight line equation, y equal to mx plus c, m is 0, y equal to c. So even t equal to 2 by 15 and e to t is equal to 2 by 30. Even t is valid for the time 5 to 10, e to t is valid for the time 10 to 15. Just put these values here and solve, you will get x bar. Okay, so this is the method by which you can get segregation model. So, and one more question was there in CRE, the last question, I think it was related to some catalyst activity. I don't know the question exactly. If you have, you can share. Okay, otherwise if we find it, we will provide the solution. So these are some questions, guys. I hope you got the answer, and the methods, how to solve, how the see. And I have also told you how you can check your marks, how can you can analyze your performance by yourself. So just check your marks, just see this, and otherwise you can go on our website, you can after getting the response sheet, you can fill up your details there, and we you can submit your response sheet there. We will love to evaluate your performance and we will provide you the expected result, okay, on our gator and predictor portal also. Okay, the links of the gator and predictor we will share at the in the description of the video, otherwise you can find it on our website also, the www.thegatecoach.com. Okay guys, so this is some questions. I also have some other questions from FM, math, economics, ep, IPC, etc. But since I don't discuss these subjects here, so I will not be I will not be a suitable candidate to discuss those things which I don't know. Okay, so the concerned faculty relate of those subjects will come in the institute and we will ask them to discuss the solutions of those questions also. Okay, so still, if you find any other questions, if you are able to recall any other questions which we haven't discussed here, you can share on our mail ID, you can share on our Facebook page, you can share on the comment box. Okay, so that's all for the day, guys. If you find this video helpful, you can share with your friends also in chemical engineering domain. And don't forget, after 15 Feb, we will come with the detailed analysis video where we will do the proper analysis of the exam and we will discuss the difficulty level and the actual expected cutoff and the marks, at what marks, what rank you guys can expect and all those things. Okay. So till then, bye bye, take care, sayonara, have a great day ahead and have a great Valentine week also. Ta-da, guys. Bye bye.